Alright, ladies and gentlemen, these notes cover special right triangles, specifically 30, 60, 90 right triangles and 45, 45, 90 right triangles. But we're going to start with 30, 60, 90s. These particular triangles have very specific characteristics in terms of their side lengths. Okay, so if you look here, something really cool about 30, 60, 90 triangles is we automatically know where the 90 degree is because, you know, it's always drawn in there for us. But the side that is across from the 90 degree angle is always going to be the length of 2x. Okay, I don't know what x is, but there is a way that I can solve for it. So whatever x is, we're going to multiply it by 2, and that automatically is the length of that side. The side that is across from the 30 degree angle is what is x. So let's pretend that this side length here was 10. Okay, so if x is 10, that means that the side across from the 90 degree angle has to be 2 times 10, which is 20. And that leaves the side that is across from the 60 degree angle, which is x times the square root of 3. And in this case, if x is equal to 10, then this side length across from 60 is 10 square root 3 automatically. Okay, so if I were to zoom in here, or zoom out, sorry, some things to remember is that the smallest side is always going to be x. And remember, the smallest side is always across from the smallest angle. Our second side, so our medium side, is always x square root 3. And our hypotenuse is always going to be 2x. Okay, so here are some examples. Find the missing sides of each special right triangle. So I know that the first thing I'm going to do, sorry, I kind of just jumped in there. The first thing I'm going to do is I'm going to label the sides of the triangle. So the side across from 30 is always x. This side is x square root 3. And the side across from 90 is 2x. This is pretty stinking awesome because I know that x is equal to 4. So if x is equal to 4, my hypotenuse is automatically 2 times 4, which is 8. And my medium side, the side across from 60, is going to be 4 square root 3. So that one was pretty nice. And if you're wondering how in the world I solved for those, I used the blueprint right above. I labeled the sides, and I used the fact that x equals 4. Looking at problem number 2. Okay. Again, I'm going to go ahead and I'm going to label my sides. So this is x. This is 2x, x square root 3. Okay, so if this is the case, the only thing I know about this particular problem is this right here. I know that the hypotenuse, which is equal to 2x, equals 10. So in order to solve for x, because that's the only way I'll be able to solve for any of the other parts of this problem, is we have a 2x equals 10. So x has to be 5. So I divided both sides by 2. So I got that x equals 5, which means that my shortest side is 5. And my hypotenuse is 5 square root 3. Okay? Which means, last but not least, I'm given this one. Okay, and if I go ahead and label my sides, I know that this is x square root 3, this is x, and this is 2x. Okay, so I know that looking at this medium-sized side, I have 7 square root 3, and in order to get that, I actually have to set this equal to x square root 3. Okay, so in order to solve for x, one of the things that we can do is we can divide by the square root of 3. And I know some people are like, oh great, now we have to do that radical thing all over again. Y'all, if it's the same on the top and the bottom, we can automatically cancel them out. So I can cross out this square root 3 and this square root 3, which means I can cancel out this square root 3 and this square root 3. So by doing that, I know that x equals 7. So my smallest side is 7, and my hypotenuse is 2 times 7, which is 14. Okay? All right, so we have some word problems here. We can go ahead and look at those. Those will be fun. A television is measured by its diagonal. What is the size of the television? Okay, so one of the things that it automatically gives me, a lot of people want to straight up do the Pythagorean theorem when they see something like this. But we're going to use special right triangles because I know that this is 30. If that's 30, that has to be 90, which means that this angle all the way up here also has to be 60. Okay, so if I label the sides, the side across from 30, so if I go ahead and label those sides, the side across from 30 is x, but I don't even have to label any other side because this particular problem is asking for the diagonal. Okay, and I know that the diagonal in a 30, 60, 90 triangle is a 2x. And I already know what x is. X is 24. So using some substitution, 2 times 24 gives me 48 inches. So this is a 48-inch television. Okay? How far is the base of the building? How far from the base of the building is the car? So they want me to solve for this side down here, that orange side. First things first, label your sides using the blueprint at the top of your page. The side across from 30 is x. The side across from the 90-degree angle is 2x. And that orange side, that little orange side is going to be x square root 3. So if I already know what x is, using some substitution again, we can figure out that the distance, that orange distance, is 18 square root 3 meters. Okay, so ladies and gentlemen, that's a 30, 60, 90 right triangle. And my favorite, because I actually think it's way easier than that, but, you know, I'm the math teacher, so I'm supposed to say that. 90, are the special 45, 45, 90 special right triangles. Okay? So, and the reason I like the 45, 45, 90 right triangles is because the legs are the same length. Okay? So, the legs, if I know one leg, I have to know the other one because they're the same. And our hypotenuse is whatever x is times the square root of 2. Okay? And then I answered this question a couple times for some people. How do we automatically know it's a 45, 45, 90? If those two angles are the same, I know that the legs are the same. Plus, we know that all the angles of a triangle have to add up to 180, and so that's how we can figure out our missing angle if we're given that. Okay? Find the missing sides in each special right triangle. Okay. First things first, label your side lengths. X, x, x square root 2. Guys, if we know one leg length, then we automatically know the other leg length. And why am I writing 8? I don't know. It's been a long day. Should definitely be a 5. Okay, and then using some substitution, we know that our hypotenuse is 5 square root 2. Okay, let's look at number 2. Go ahead and label your sides. Oops. X, X, X square root 2. So to get x by itself, we divide by the square root of 2. And I see that the square root of 2's cancel out on both of them. So by definition of crossing out, solving for x, we get this x equals 8, which means my side lengths, my legs of the triangle also equal 8. Okay. All right. So ladies and gentlemen, let's, do what we do best. What is this? This will be x square root 2. This leg over here is x, and this leg over here is x. Okay, so I'm going to do this work. I'm going to scroll up here. X square root 2 equals 12. And you guys know from previous examples that we have to square root, or divide by the square root of 2 on both sides. So they cancel out here on the left-hand side. So we get that x equals 12 divided by the square root of 2. This is where properties of radicals come in because we can't have a square root in the denominator. So we're going to multiply both sides by this, or the top and the bottom, by the square root of 2. So we end up with 12 square root 2 divided by 2 because square root 2 times square root 2 is the square root of 4, simplified as 2. Okay, and so this is where I can't simplify the square root anymore, the radical anymore, but we can take 12 divided by 2. And 12 divided by 2 is 6 square root 2. So there's my x value, which means my side lengths are 6 square root 2. Okay. All right, so ladies and gentlemen, looks like we have a baseball problem. What is the distance between first and third base? So we're asking you to solve this distance. Okay, now if I rotate that picture just a little bit, I have a 90-degree angle, and it looks like these other 90-degree angles have been cut in half. So I know automatically that they are 45-degree angles, which means that the sides of my triangle here are both x. And by definition of a 45, 45, 90 triangle, the hypotenuse is x square root 2. So I know what x is. X is 90. So my distance has to be 90 square root 2 feet. And if you're wondering how in the world I got feet, it tells me in the problem. Okay. The perimeter of a square is 28 centimeters. So just as a reminder, because I think some people got confused, a square, I mean, obviously that doesn't look like a square. Hold on, there's a way for me to make a square in this app. Ha ha, ha ha. That's, sorry, definitely not a square. I don't know how to make a square. All right, I lied. So you guys are just going to have to deal with my horrible square drawing. Okay, it kind of looks like a rectangle, but whatever. Perimeter of a square is 28 centimeters. That means that every single side, when I add it together, has to equal 28. But on top of it, I know it's a square, so I know all these sides are congruent to each other. So to figure out what one side length is, we're going to take 28 and divide it by 4. Okay? Because that'll tell me what all my sides are. So all my sides are 7. Okay, and I know that it's a square, it tells me in the problem, so all of these are right angles, and it wants to know the diagonal. So very similar to the last problem. And notice there was no picture here, so I had to draw one. Ladies and gentlemen, if there's no picture, draw it, okay? But if I go back through and I label my sides, I know that this is x, and my hypotenuse is going to be x square root 2. So the diagonal is going to be 7 square root 2 because I already know that x is 7.